en nu heb je 2. Er zijn 2 onderwerpen geweest in deze.
Ja, maar dat is ook patchen, dat probleem.
Ja, we hadden nog niet alles. Uw hotspot en client moeten gepatcht zijn.
Ja.
Alle twee.
Is het zo? Deze dingen als alleen een client?
Nee.
Maar hebben we ook
Palen.
Ik dacht dat ik gewoon client zijn.
Nee.
Dus je probeert die voorstellen van het amusement.
Want we zijn zich al vol, maar je dan muziek. Zoals in de bijen. Alles mooi gaan de tijd makkelijker. Alles gewoon op netwerk te zetten.
Right, everyone, thank you so much for coming. It's really nice to be here for the first time at Mobile Vikings. Thanks everyone from Mobile Vikings and Jeffrey for organizing this. I'm gonna let Geoffrey present himself as he talks, but he's been a member for a long time of our meetup. You've probably seen him. So I'm very, very excited that this is the first time he's giving a talk, and I hope we can all take him as an inspiration for hopefully further talks from our own members in the future. The short program for today is this talk. Then we're going to have some more social time. Right before that, I'm also going to raffle, as we usually do. And yeah, that's pretty much it. After that, you can always go grab some coffee, there's drinks, so feel free. Okay. A round of applause for Jeffrey. Just one more thing, we're also live, so
We had pizza.
yes. Right.
Hi, I'm Jeffrey. You're here at Unleashed. We manage 3 brands, as you may know. Stevie, Gym Mobile, and Mobile Vikings. We got some jobs on our page. One is as a telco support engineer, and then we have some positions at help desk. And a third-party relationship manager, if I'm correct.
Correct. Nobody knows exactly what it is, but that's part of the deal.
Yeah. Today I'm going to be talking about functional programming in PHP. I did a presentation about this in Python. That's a language that we use at this company for most of our stuff, for our website. Basically all other stuff that we make. And I thought, why don't I try this in PHP? PHP has some stuff that lets you do functional programming in some fashions. So I'm just going to explain some of these concepts to you. Let's see. Why did I start doing these talks? Started with a book called Learn You a Haskell for Great Good. Basically about the Haskell programming language. It's sort of hyping on the internet, so I just jumped right on it. And while Haskell is not a language that I've started using for projects, it's a little inaccessible, and if you want to work with people, it's not really an option because there's not a lot of Haskell programmers. But I did learn some concepts which I started using in Python, and kind of makes code a lot more readable. And maybe you'll see why. So I'm just gonna show you some functional concepts. These are basically concepts defining what functional programming is and why it can benefit you. First concept is currying. It doesn't have anything to do with curry in the background, but it's taken from mathematics actually. This is the definition. It's a definition that I partly copied from Stack Overflow, and I made it kind of that you can understand it. I think it's easier to understand from the definition on the bottom. Basically, it is if you have a function that accepts multiple arguments, you kind of return functions that take less arguments than what I had in the beginning. So I think I'm going to show you an example. Let's see. What do I have? I have 2 files. I'm going to start with this one. Let's see. So here's an example of I've got an add function, and there is this sqrt add function that kind of does the same, but instead of doing the add operation, it returns a function that uses the first argument and asks you one more argument, and you can call it in this way. Basically, the current add for returns a function that accepts the second argument and this way we can write it in this fashion. If you execute that, let's see, you basically just get the same results. This does exactly the same as this. And I think I got a practical example. It's not really practical because it's all mathematics, and probably not going to do this in your own group. But you can imagine you need a function, and you can build this function out of your multiple argument function, and you can define a new function this way. This is a very simple way of adding it. I use a library called functional, and this has a query function defined. If you call this query function on your function, you can basically call it with a single argument, and at the point that you have all your arguments filled in, you just get a value. So what this does is you make an add5 function out of this add function by applying 5 as the first argument. And as you'll see, this will return like 5, 8, and 10. Should be very practical. That's 6, 8, and 10. There you go. I think that's at 5, 8, and 10. So that's querying. In the beginning, it's very hard to kind of give practical examples, but as you start coding with this, you start learning how to make functions that accept multiple arguments, just so you can query them later and use them as functions and like map statements in which you accept one argument, and that'll show you later in an example. I've got several left. Immutability is another definition. PHP is by default a mutable language, and this can cause some confusion because when you give an argument to a function, you're never sure if this argument is going to be changed, except if it's not a reference. But if you pass an array in PHP, it's hard to kind of know what happens in this array. Is it going to be changed, or is it going to be the same after the function? Makes debugging hard, and makes testing difficult as well. And if you have immutability, stuff like threading, parallel processing becomes a lot easier because in a thread a variable isn't going to change. But if you have mutability, it could another thread could access that variable, change it, and that could cause problems. It's basically this slide. What I just told you guys. Yeah, that's basically this slide. Oh yeah, the last point is an interesting one. If you have an immutable language, kind of means your compiler knows this object is immutable, so I can use this as a reference in another object because the program knows this is never going to change, so it's safe to use this multiple times in different. So basically, when you make a new array out of an existing array by adding an element, you use a reference of that first immutable array and you just paste an element after it. So memory consumption seems high if you get an immutable language, but since it uses references to immutable structures, it's actually quite good. I think that kind of defines pure functions as well. A pure function is basically a function where if you give it one argument, if you call that function with that same argument, you expect to get the same output every time. An example of an impure function is, for example, a function that uses a global variable. When you call it the first time with an argument 5, it could return 6 if your global variable is 1. But if you change that global variable to 2 and you call it that function with an element 5, you get 7, seeing if it's an add function. But that's an impure function. What you should do in functional programming is a function that accepts an argument should always return the same, should always have the same return value if you give that same argument to that function. Stuff like random, you shouldn't put that in a function, but you should put that in a monad. But that's stuff for later. I got an example on pure functions. I'm gonna just open it in my editor. Yeah, pure. Okay. That's not helpful. Okay. So an example of an impure function is the first one, where you have a constant here, which you use in this function. If this constant changes, you could supply the same argument here, but it'll show a different output because you change your global variable. In this function, I define a base directory, and this is kind of currying, like partial application, but it uses currying. You can make a function out of that pure logpad function, and you give this the argument on the right a value of logpad, and this returns a new function. This function, which I'm using here, and if I execute that, I'm gonna get exactly the same, but the second version is pure, and the first version is impure. That's the example. Function composition. This is a very interesting one. Basically, function composition is applying the result of one function to another function. So if you execute a function, you use that return value as the argument to the second function. Mathematically, it's written like this. And in languages like Haskell, you also write it like this. I found a library in PHP to kind of do the same thing. Let's see, composition. Okay, let's see. What happens here is using the string repeat function to make a function mass stores by giving it first argument of a store. So basically, mass store will be a function that accepts another argument. String repeat asks an argument, string, and then a number of how many times you want to repeat that. So mass store is a function that fills in that first argument with an asterisk, and then you have one argument left. So if you call mass stores with 10, you get 10 stores. That's what that does. And then I make a mask password function by composing the length of a string to this function. So what this does is, if you give this a string ABC123, string lang will evaluate to 6, and that 6 will be applied to this function. And that kind of becomes a new function called mask password. This would be the imperative way of defining it, which some people will find easier. But these essentially do the same thing. I'm also going to run it. Let's see what composition. It does exactly the same, but it's written in, the first one is written in a functional kind of style. This one is how you would usually write it. I think in this fashion, I would write it the second way. I would write it the first way if I maybe wanted to annoy people. Because I think the first way is kind of far-fetched in this case, but it was kind of an example. How can you use this to do some fancy stuff? Then you have monads. I gotta be honest. My understanding is very. I still need to get into it. I know some monads, like the maybe monad, and basically a monad is kind of a. I would describe it as a box. A lot of people will disagree with me, but I think it's an easy way of representing how most monads work. So basically, a monad is a box, and you kind of define how to get stuff out of this box, but you also define how to get stuff into the box again. So basically, when you bind a monad to a function, that function knows how to get stuff out of that box, and the function also knows how to get stuff into that box again. An example of a monad is a maybe monad. That's when you kind of wrap your variable into a maybe monad, and depending on what that variable is, it can, if the variable is null, or maybe we'll say, okay, there's nothing, and when there is something in that monad, it'll know, oh, I can apply a function to that now because it's got a value. I think I've got an example, and I hope I can explain it. Let's see. Oh, I do have a maybe. Okay. Let's open it here. Okay. So this. Oh, that's weird. Yeah, that's the maybe list. Oh. Okay. We're finally in the file. Basically, here I wrap two values in a monad, a value of 5 and a value of 0. And I bind some kind of multiply function to it, multiply my tree, basically. And in the first case, it will just return 15, and in the second case, it will, I think it will give me nothing. Yeah, it just returns this kind of weird structure. So instead of failing, it tells you if there's nothing in there. And based on that second one, you can apply more functions to it, and we'll just keep saying nothing. So that's a maybe monad. A monad is actually something to overcome the fact that you have to use proof functions, because in a monad you should define your imperials. But that's the way it works in Haskell. You've got all the functional languages that don't really apply these principles, but they were different. That was the example. I've got some more examples. I think this was a fun one. Take a while. So there's a problem here. I want to know all of the values where the square of the value is less than 1,000. And I think this is, I think a functional way of doing this is creating like a generator that creates numbers up to infinity, and then define a function that consumes this generator up to a point where you don't have, well, up to a point where you have this condition here that you define. So you supply take while as a callback, and that callback should return a boolean whether there is still stuff left to consume. So in this case, you're sure that whenever x grows, it's going to be bigger than the previous value. So at one point, you're going to reach a maximum value of 1,000 here. And I've written this in two ways. This is the first way. You just basically create a closure, and you give that closure to take while. So it'll keep taking values from this generator until this value reaches something that's over 1,000. The second one I've done with composition, and basically what this does here is it'll square the number here. This is also another library I used. In functional languages, your XX is a function which you can just basically use as a function, so you can do like XX brackets and then your first element. PHP doesn't allow this, so someone made kind of a library where you can say operator, this operator, and you have to apply 2 to it. And then that function expects one more argument, which is the left argument. And you're gonna throw the return value of this to this operator, which kind of checks if it's less than 1,000. And this is essentially easier to read than the first one, if you count this out, I think. But if you learn how to understand how composition works, then it's quite nice. One thing to get to this is kind of looking what this function does. And that's essentially pretty simple. It does two things. It calls this function, and it calls it with 2 arguments. First calls it with x2 and then 1,000. So we're probably going to need this. And then when you also apply this as a function, you kind of get this. So this is the functional way of doing this. Later in this presentation, I'm going to show you how you can actually see this happen. I think that's in the next part almost. But first, there is another example on filter and reduce. Filter and reduce is something, imagine if you have a loop where you have an if value in that loop. So you're looping something and then you do a check. And then depending on that check, you want to raise a value like a sum. So you're looping a collection of variables. You're doing an if check. And in that if check, you're appending the valid elements to an array, and then you're doing a sum on it, for example. That's kind of what filter and reduce does for you. So basically, pretty simple. I've got just a structure of people, and what I want to do is I want to kind of sum the credits of the people that are older than 18 years, or 18 years old. So this is a simple closure that I can give to my filter function. And filter just basically gives you an array and applies it to the collection on the right side. Well, filter basically creates an array using the callback on every element of this collection here. Filter is also a library from iter. So filter doesn't return an array, but it returns an iterator. If it wouldn't return an iterator, you'd have to go over this array multiple times. Now filter doesn't really do anything. It starts doing stuff in this when you give it to reduce. Because reduce will take that iterator, you give it an initial value of 0, so credit becomes 0, and then you keep kind of summing the credit of a person, and then in the end you get your result. So this starts consuming this iterator, and it just keeps appending credit to your initial value, which is 0. This basically does the same thing by just using a different library. This is a pretty cool library. You can create a collection from an array, and a collection's got several nice functions like filter and reduce. This doesn't use classes, this just uses functions, this uses classes. This one is more elegant than PHP in my opinion. But they do essentially the same thing. Let's see. PHP, reduce. So I get 320 for both cases. Okay. Things to improve in PHP that would make it a better language for functional programming. The composition syntax, like Haskell has. And I want to show this to you quickly here. So this is a Haskell shell. And I want to, oh yeah, there was a problem what I wanted to do in here. Oh yeah, the problem we did earlier, the squares that are less than 1,000, in Haskell is pretty easy. If you think back to the mathematical composition, where you start left, or you start right and you keep working to the left, composition is pretty easy in Haskell, and it's done where in PHP your check was on, I'm just going to open it on this side. Which one was it again? It was, I think it was composition. No, it wasn't composition. Bear with me. It was, take a while. Okay, I'm just gonna grab 1,000. 1,000. No, 1,000. Okay, that works. Oh, let's take one. Okay. Cool. So basically, this is the one that I'm gonna write in Haskell, and basically the only difference is in Haskell you have to work from the right to the left. So basically, this function is gonna come here and this function is going to come to the right. So basically, you just flip around. But I think it's easier if I kind of define these functions. So what you can do is then 1000 equals, and then you can do this. And if you then call this on 60, you get true. If you call it on 1000, you get false. So this is a way you can kind of make less than 1000. And if you want to make a function called sqrt, you just basically do it. No, it's actually this. So if you have squared 4 or 50, you get 60. So that's the way. And then you just basically compose them. So basically, what you get from squared, you apply to less than 1000, and then you take an infinite collection. Ooh, wait a second. That should work. Should that work? I think if I write it like this. I kind of knew this wasn't going to work for some reason, even though I did it a few times. Nah, may actually be. May not be. Okay. This is kind of how it. Oh no, I didn't. I forgot an essential piece. Of course, that was it. And then it's less than 1000. Okay, that is what it should be. If I kind of open the PHP example, which is a bit longer, but it does essentially the same, you also get an array from 1 to 31 board examples. But the Haskell way does it elegantly because composition is kind of built into the language with this operator, this dot operator. Plus you also got infinite, like lazy, this isn't actually evaluated until you start taking from it. So you could imagine that this starts hanging because it just keeps generating numbers, but it's just a lazy kind of range, which in PHP can be fine like this. I'm not sure if you can define an infinite range with PHP in a different way than this. If someone knows, but this was my way. Automatic currying, which is also easy to explain in Haskell. If you have a Haskell function called add, let's see, add. That's basically add function in Haskell. But if you do add 6 and you apply that to it, you have a function called add 6. That basically works like that. You don't need to do stuff like curry and then add, and then it just knows. Oh, you supply 1 argument, accepts 2 arguments. So I'm just gonna give you another function that accepts 1 less argument. So that's basically what automatic currying does. New languages like Elm, which is kind of a functional version of JavaScript, they do this as well. PureScript, also functional JavaScript, which has been growing in popularity, also has automatic currying. It's convenient, and you'll see practical examples when you start using it, but it can be convenient sometimes. Now I'm just using math problems because it's easier to kind of get a grasp of how it works. And then there's the short function syntax. This is a PSR that someone sent on the PHP page. Imagine if you could, instead of supplying this function to filter, instead of this function, it naturally becomes a little easier to read. This I can show you in a, well, basically in Haskell it's this. But in Elixir, for example, the syntax is, let's see, if you've got, for example, 5 and you want to map it to something, let's see, array 5, 4, and you map it. What you do is, so if you want to kind of multiply all elements by 3. This is the way to do it. Let's see. So you get 5 and 18. So this is kind of a short syntax, because the usual syntax in Elixir would be it's like the syntax in Ruby. So basically add, do, and then and that's your function. Now it won't work because you're not inside a module. But this is the usual syntax. But if you want to use the closure syntax they supplied, you would with kind of an alternative syntax. The cool thing about this is you don't do stuff like return. It'll just return the last statement in this function. Plus you lose the brackets, you lose this. And in Python, for example, it's called a times 2. So it's a lot shorter than just typing out the entire syntax. And then basically, apparently in PHP you have to pass functions by their name and a string, rather than just supplying the name of the string to a function. And this is confusing. This is why I sometimes just define closures instead of functions, because you can just use the variable name. Part of this is you can make typos in strings, and if you make a typo in a function name, usually your Vim or your JetBrains, your PHP storm will tell you that there's an error here. And when you pass strings, you'll just see it when the program crashes. That's basically the presentation. Are there any questions?
You have some practical use cases for this? Like for instance, seeing these calculations, you do payment transactions, and you want to make sure that the VAT is applied on all instances correctly. Is that?
That's also something you can do with a map. You could have, for example, a function calculate VHD that accepts an argument amount, and then basically if you get an array of certain amounts, you can just basically call map with that function on that array, and you get a new array. There are use cases. But I think functional programming and imperative programming, I think they're strongest when they're combined. Some problems are easier to solve in an imperative manner, and some problems are easier to solve in a functional manner. I think it's all about readability. Part of why I don't like Haskell is because it's not very familiar at all. And a language like Elixir, it's a new language that popped up. It's based on Erlang, and it's primarily used to build web applications. But that kind of takes a lot from the Ruby syntax, and it becomes a lot familiar than Haskell, because Haskell just gives you a ton of mathematical stuff and monads. And at one point, you're just gonna. It's nice to use the concepts, but the language, I think it's a bit like learning C++. You have to work in it for years until you're actually a guru of this language.
Yeah, but I do see the added value of constructing functionality, especially from a debugging point of view, where you want to implement like, okay, at this point I want to have like a additional check.
Mm-hmm.
So you can stack up all kinds of additional layers within your structures. I think that it's more of a mind shift kind of thing. Right?
It is a mind shift because I've also needed several months to start seeing patterns. At one point you just see a lot of loops and loops within loops, and then you kind of see, oh well, what if I use a map here and then another map, and essentially your complexity of your program. So in the beginning your program runs like this, and then simply by applying some map and some filter functions, you can make your program run more like this without a whole lot of indentation. But it takes a while to start seeing these patterns. For example, decomposing of functions. I think that's a very exotic one. You can do a lot of cool stuff with it, but you have to start seeing it. And I think it's primarily a mind shift, and I think the annoying thing is that everyone starts programming imperatively, and that makes it very difficult to work in teams if you're doing functional programming, because everyone needs that mind shift. I kind of try using the basic concepts like using these functions that take function as an argument, like map and reduce. But I tend to use less stuff like composition because it tends to make you a bit confused. The composition in Haskell is confusing, but what I did here in Elixir, this is kind of like how your shell works. This is the pipe operator. So basically, what this does is this gets given to the first argument of this. So basically, this gets put into here as a value by getting piped. So if you want to pipe that to another map, you can just basically do the same thing. And you say it's a-2. And then you can just keep piping it on. So this is also called composition. But this is just another way of showing it. This is a less mathematical way, but it takes more from the Linux shell, from the bash shell. Usually you also type this on the next line. So you just basically get a bunch of pipes. And it kind of looks, it's nice to read. Elixir is like a functional language that I started grasping just straight from the beginning because it's familiar with Ruby programs.
Yeah, I see some of these concepts reappearing in several middleware applications in PHP. So it's not like it's completely new, but yeah, it's like the middleware is like the transition between the regular programming practices and this functional programming. So.
Exactly. I think the cool thing about languages like PHP, Python, and Ruby is that you can define classes work imperatively, but you can also like imperatively, like in OOP way, it's called object orientational programming. But you can you can make a combination. This is cool in a functional. This is a cool problem to solve in a functional way. But I can still use my classes. I don't have to shift to this pattern entirely. But if you use a language like Haskell, I think it's very hard to wrap your head around how do I structure a program. It was like only like when I was 1/3 in the book, and I still didn't know how to get a program running. I just knew how to solve some weird math problems. Because that's what the book learns you in the beginning. Just you keep solving these weird math problems that you never thought about. That you would never use in the program, but it's a way to kind of learn how do these functions work. And after a while, you start using them in not only math problems but also just practical problems. But Haskell for me was something that was needed to kind of shift my thought process. It's a language that I'm probably never going to use, but I'm very happy that I read the book.
Awesome.
What book is it that you wrote?
It's called Learn You a Haskell for Great Good. I think it's actually a free book as well. And it kind of learns you Haskell in this very idiotic manner. It's got like these weird images in the book. It's a playful manner of learning Haskell. And it's beginner oriented. If you start reading it, it doesn't require you to be accustomed to functional languages. You can just learn it as a beginner. And even if you're not going to use Haskell, I think it's cool to use the concept in other languages. There's also a book called 7 Programming Languages in 7 Weeks. And they explain 7 languages there's 5 languages that I've never heard of, but they just use these languages to learn the concepts. They don't expect you to use this language, but it's probably just a language that has this concept defined in a very nice way. So it's easier for you to learn.
Did you find any other resources to learn functional programming that are not language specific that just cover the principles and ideas?
I think the best book is probably 7 Programming Languages in 7 Weeks. That's probably best way of learning the concepts. Learn your Haskell for grading is probably a book that I think, well, maybe there are time. It's weird to give you a favorite, but the one I started with was that Learn Your Haskell for Grading. And then I started reading about Elixir, which I want to use for my own web development. I think it's a very, I think it's a language that's going to grow very big in the web development, because Haskell is pretty much made to run on multiple cores. So Elixir was kind of made for very, very big web applications, and it's also kind of built on microservices. It's called umbrella projects in Elixir. So basically, the way to program in Elixir is get just a lot of projects side to side. So you don't create one big monolith, but you can create multiple services that talk to each other. And the cool thing is you work on the Haskell virtual machine, so you can just send messages to each other natively. Doesn't require some weird socket framework. You just send messages using the Haskell VM. And the Haskell VM, you can just store threads in it, like they don't use memory. Haskell threads are very, very lightweight. So basically, most of the stuff you just store in a worker. The way to program in Haskell is in Elixir is also just programming the happy flow. And if your program crashes, you just store it up again. Because it's that easy to just store a new worker. And then, so when you get exceptions, you gotta build your program in a way that when an exception does happen, your state doesn't go lost. And that's mostly because you don't really keep state in a functional language.
Right. Thank you. A round of applause. So, usually we raffle here for the people who commented on the talks from the previous meetup. There were 3 relatively fast talks, but there were very few comments. So we're not going to raffle that. We do have a nice raffle prize from PHP Limburg, and that's a power bank. So we're going to raffle that, and what we're going to do is, do you actually mind using your computer?
Oh yeah, sure.
We're going to do it similar to the previous time. We're going to start numbering ourselves since we're all sitting down. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 14, 15, 16, 17, 18, 19, 20, 21, 22. And we're going to go to random.org if you don't mind.
Random.org.
Write a random Haskell.
Yeah. And you can set there the maximum.
Is this included?
Yeah, I guess. 12. Yay. Right, so thank you for coming back. Next meetup is going to be hopefully around mid-November, and I'm going to announce that too. It would be great to see you all there as well. And we're always looking for speakers, so ping me if you need that. And we might be planning some GDPR topic in the future, not confirmed yet, but it would be nice to do that as well. We're also looking for venues for next year, so if you're interested as well. Thank you guys.